I just want to review our perfect squares because we're going to use them a lot again today. Remember that 1 squared is 1. 2 squared is 4. 3 squared is 9. 16, good. 25. 36. 49. 64. Get to larger ones, we got 81 and 100. 121. You're not cheating, are you? 144. 169. 196. 225. 256. Do you remember those? And yesterday we talked about adding and subtracting radicals. Are we allowed to add and subtract 2 roots of 7 and 5 roots of 7? Yes, because the radicand is the same. And so we get negative 3 roots of 7. Are we allowed to do 3 roots of 18 plus 4 roots of 50? We have to first simplify the radicals so the radicands are the same. What's a perfect square that divides evenly into 18? Good, I've got 9 and 2. What's the perfect square that divides evenly into 50? 25 and 2. Good. This was the question that came up during first hour. People said, what do I do with that piece? Again, square root of 9 is 3. It's not 3 plus 3, it's 3 times 3. So ends up being 9 roots of 2. The square root of 25 is 5, and it's not 5 plus 4, it's 5 times 4, which is 20 roots of 2. So 9 roots of 2 plus 20 roots of 2 gives me 29 roots of 2. So there's a little bit of a review from what we've covered so far. Today we want to simplify radicals using operations of multiplication and division. In order for a radical that must be simplified, it must have all perfect squares simplified and you may not have a radical in the denominator. May not have a radical in the denominator. There's a lot of rules in mathematics, and most of them make perfect sense, and I would argue them till I was, blue in the face. But in this situation, I have to admit, not a big fan with the whole radical in the denominator thing. I think it's kind of silly. A lot of math people feel the same way. It seems like a rule is kind of made up that doesn't have a lot of merit behind it, but we just kind of got to live with it. And so you'll have one lesson this year we talk about radicals being in the denominator. Now, in this situation, it asks you to simplify the radicals. We have square root of 4 over 9. One nice thing about radicals is that you can divide the square up among 2 parts. So the square root of the top divided by the square root of the bottom. And as you notice, this is not simplified because you have numbers that you can take the square root of. You also have a radical in the denominator. But it works out kind of nice because the square root of 4 is 2 and the square root of 9 is 3. So the square root of 4 ninths just becomes 2/3. The square root of 25 over 49, again, that's just the square root of 25, divided by the square root of 49, which is, as you said, 5 over 7. Square root of 1 over the square root of 256. Just 1 over 16. So in these three examples, you can see you can take the square root of the top and the square root of the bottom. But in example 4, you can't really take the square root of the top. You have the square root of 6 over the square root of 25. And that's okay. Don't worry about the square root of the top. Just focus on the bottom. We leave it as the square root of 6 over 5. And that's acceptable because you have the square root in the top. There's no square root in the bottom. If it says negative, then your whole answer is just negative. So we have the root of 2 over the root of 49. You can take the square root of 49 to get 7. So we have negative root of 2 over 7. And for example 6, again, the square root of 7 over the square root of 100, which is just the square root of 7 over 10. So in these situations, it was nice because the denominator always was a perfect square. What if the denominator is not a perfect square, like in example 7? This is where we run into a problem. This can be rewritten as the square root of 2 divided by the square root of 3. Can I leave it like that? I can't, because I have a square root in the denominator. So you may know how I get rid of the square root of 3 in the denominator. I multiply the top and bottom by the square root of 3. Now let's understand what we're doing. What is the square root of 3 divided by the square root of 3? I heard nothing, I heard 9. Something divided by itself is 1, right? So we're just taking this expression and multiplying it by 1. And we multiply by 1, that doesn't change its value. It just makes it look different. So notice what happens. The square root of 2 times the square root of 3 is the square root of 6. And on the bottom, the square root of 3 times the square root of 3 is the square root of 9. Well, you say, well, Mr. Gens, you still have a square root in the denominator. Not really. We have the square root of 6 over 3. Notice when you take a square root times a square root, the square root just disappears in that situation. You just end up with 3 in the denominator. And so now we say that that is simplified. We say that we have rationalized the denominator is the phrase. We've rationalized the denominator. It used to be an irrational number. It's now a rational number. So here I can multiply the top and bottom by what? Square root of 2. And in the top, we get the square root of 10. What do you get in the bottom? The square root of 4, which is 2. What do you think people generally try to do for number 9? A lot of people multiply by the square root of 6. I'm going to give you another option. Notice how I broke the square root of 6 up into 2 parts. I have a square root of 3 in the numerator, and I have a square root of 3 in the denominator. What do you think I can do? I can cancel them off because square root of 3 divided by square root of 3 is 1. So you have 1 over the square root of 2. Can I leave that as my answer? No. Multiply the top and bottom by the square root of 2. Notice in the top we get the square root of 2. And the bottom you get 2. Three problems left. Multiply top and bottom here by the square root of 3. And we get 6 roots of 30 divided by 3. Is that done? Very good. Notice that 6 divided by 3 is 2. So this becomes 2 roots of 30. Similar in example 11. We multiply top and bottom by the square root of 2. And we get 8 roots of 14 over 2. Do I leave that? 8 divided by 2 is 4, so I can rewrite this as 4 roots of 14. Good question. So you see how we get 8 roots of 14, right? Now on the bottom, square root of 2 times square root of 2 is the square root of 4. And the square root of 4 is 2. So we're just skipping that step. All right. So last example, I'm not a big fan of working with really large numbers like 35. So how about you say we reduce 35 a little bit? What are 10 and 35 both divisible by? So I'm going to rewrite this as negative 4 times the root of 5 times the root of 2. You said that both of these are divisible by 5, so notice how I wrote it as the root of 5. In the bottom, I'm also going to write the root of 5 times the root of 7. So I've now shown that there's a square root of 5 in both of these parts. So what can I do? Yep, you can just divide them off. So now you have negative 4 root of 2 over the root of 7. Now, I'm not done, but at least I'm working with smaller numbers now. Times by the square root of 7. We get negative 4 roots of 14 over 7. Can you divide 4 and 7? No. 14 and 7 you can, but the 14 is under the square root, so you don't divide if it's under the square root. Okay. So that's that. So you're ready to work on your next piece. So if you turn to your worksheets, you can start working through that. See, I told you guys it'd be 12 minutes, and look at that, we're 12 minutes, 30 seconds. Length of the